Hello, my name is Philip Adelabu, and I want to briefly explain how tackle a challenge. The challenge is how do you analyze data, okay, using Python and Anaconda. Now, the data in question is the data of an e-commerce client's behavior. Now, this is exactly how that look like. This data here, customer event CSV, that's a comma separated value. Now it is open here in an Excel format. Now if you look very well, this is the entire data from the cargo.com that we get it from. Now there are about 6 to 7 columns. 1 2 3 4 5 6 7 8 9. Okay, 9 columns. Now we have the time, event time, we have event type, we have product ID, category code, brand, price, user ID, and user session. Now the major thing here that we try to observe is like the user behavior, the client behavior online. A user who goes online can view a product, can put the product in the cart, or can actually remove the product from the cart. He may also want to purchase a particular product. So we have purchase, we have view, we have remove from cart, and we have a cart. Now this is the output that we are trying to analyze and try to predict if a user may want to do any of these things. Now we have different features, but this will be our target label or a particular output. Now let's come back to our data structure here. We have the code that's called code.py. This is a code in Python here that I'm going to explain shortly. Now also we also have a Jupyter notebook where we can run our code. On one notebook is because there are a lot of already installed utilities within the notebook. Now to run the program, we say run proc, that's the file name, then code.py. This will actually run the particular file here that we have, and they are in the same root directory here. This is a notebook and this is a code. This is where the data is. So if I come back here and click on run, the program should start running. But while it is running, let us come back again here and try to understand most of our data and then go back to the code. Now if you look very well here, see that we have about 1 2 3 4 5 6 7 8 9 columns, and certain columns may have empty value, like here category code. There are a lot of empty not assigned value here. Okay, also if you look at the brand, there are other fields, empty fields or empty column rather in the brand, and most of the other ones have failed values. Now these are things to observe very well. And also we have that this is the time is 2019, I think, yes, and the date of that particular record. Here we have event type or the behavior of the user is here. Now this is in character format, like categorical format. Here we have numbers, here we have number and e, that is like kind of an exponential value number. So here we have alphanumeric, like data, a number and character mixed together. Here we have number, and if you look very well, there are decimal number, and this is a double number, that means a float number. This is a price. Now we'll look at the this thing to actually understand the correlation between these five. But before then, before going back here to, let's come again back here while our program is still running. Let's come here to see the source code exactly. How do I know the file the code is still running? Is from here. When I look at this sound clock class, I know the code is still running, and if it's still running, so I can also tell from the bottom here that it has reached him. Now while it's still running, because here is saying exactly that loading database, the database is about 1 million plus, let's say, in data size. If you look very well here, we discover that the data is so much that it takes time to load it. You have 1,048,576 rows. That's a record. That's a lot of data, and it might take some time before my program could load all those things. But while that one is ongoing, let's come to the coding section. Now I needed to import all those particular tools and library here before I could start working. Let's come here. This is a Panda. Import Panda. Panda is usually used for data analytics, data management, data modeling much. This scaling is also for the machine learning and other tools there to like training test plates. How do you divide the data into train and test? We also have the sample input data. These are meant for data encoding. You have the numpy to handle a large volume of arrays of data. Matplotlib is for plotting. These two are for plotting. So if you go here, there are a lot of tools that we use. All these are most them for the machine learning. This label encoder for encoding. Pipeline is to how you transform data from one level to another level. So also we have the multi-purpose partition classifier. We also have the random forest classifier. All these are also part of the things that we need within the program. Now here we try to make sure that any error or any warning should be ignored instead of wasting our time with error analysis. Our program is still running, so while it's still running, let us go back again and try to explain much our code. Now here is a little function to display some message on the screen. Likewise here too, this message info here is just to display message on the screen. Now here it is where we loaded our data. We have this panda to load data from where it is in the folder data, and this data file name customer-event.csv, a comma separated value file. Now it's going to load it and make it available to the system down here. This is a function just to do that purpose exactly. So if you come back here, the load data set is not called down here. This function that was created here that will load or to call or to bring in data into the program now here has been called here exactly to retrieve data and put here as a data frame. Now here exactly we make sure that because the data is so large, about 1 point something million, we just cut out the first 2000 of the data just to shorten the time. So we now put it inside the diff frame here. So diff frame now is not holding a data frame of no more than 2000 records. Here is just to print out data set loaded. Now here we also want to just look here to get the information, a brief information about data frame. Let's come back again to see if we could see that one while this thing is going here. Now this is a brief information about the data here. Now we have event type 2000. That means we have 2000 record of event type. You have event time and event type, product ID, then category ID. Don't forget that we actually cut it from here, 2000 years from here. So we have this one here, the price. Now if we look very well, the category code, it has only 38. That means a lot of things are actually missed down here. And also user session as 1900. That means only one. So if you look very well, we have the brand and the category code who are missing. They're missing a lot of information. Let's come back to see again our data here again. This category code is missing a lot, and also the brand too is missing a lot. Probably we're not really want to use that one in our data analysis because a lot of things are already missed over there. So we'll likely drop that one for possible good result of the machine model development. So also here too, let's come back here then to see again. Now here also to describe a brief description of the data frame that we just got. Here I want to sum to see the one we saw here, looking at the missing data out of 5000 or out of 2000, right? Because I've changed to 2000. So this one just sum up what is not null here, what is null here, to see all those things down here exactly, and this is not null here. So we see that no, you have 2000 non null, that non null. So it is the work of this one exactly that gave us that one. Now here we want to count the event type, the value count the event type that are major targets here, the view, the purchase, cart, and remove from cart. These are the event type. We want to count exactly how many of those things are in the let's see if it has come already here. Okay, here we have it here. This is events count exactly. Now we have the view as about 845, the cart as 698, the remove from cart as 349, the purchase as 108. Definitely the view has a larger number, and the cart as the next larger number, then the list is the purchase. So this is what we did here, because we could have a frame out of 2000. So this is what exactly we have to do for that one to see. Now if you now come down here to show this just to plot the graph between price and events, it's scatter form. Now let's come down here to quickly explain a little bit of our code down here. Now here, okay, here we just copy, like we have a copy of data frame to a new particular name called data. So data now is not the one holding the record of the first 2000, just to make sure that we don't compromise with the former one. We work with this one first to see if anything goes well. If anything goes wrong, we can fall back to our data frame to get a new fresh copy. Now here we want to get the unique, we want to uniquely get our event type into this particular label class. Don't forget that there are 4 different types of event. We have the view, we have the card, then we have remove from cards, and we have the purchase. And if you look in our column here, we have almost a lot of them. So we just want to make sure we have uniquely 4 of them in an array. That means this label class name will have only 4 instead of the old 2000, just to separate them there. So after that, now we'll not copy, we will not make sure that the entire data type, a copy of it is sent to Y label. Why is it so? Because we are trying to make sure that this particular record, this particular column, event type, is the one we want to make as a target, as a Y label. We are writing a machine learning towards the direction to see if we can predict a particular record or a user coming online. We can predict the behavior based on this particular target. So this is a target, it is a target column for this machine processing model. Now also here we want to make sure that our label class name here has been transformed into a number. Do not forget that what we have are categorical values. We have the view is not a number, it's a character. But now we want to assign each particular label to a number. So this is what this one will do. Label encoder fit transform the array name into this one. So that means each particular label will not have a number. Let's see if we can, it's already here displayed, so I can just show you. Okay, exactly, here it is. Now these 2 lines here, the first line here is the uniquely retrieve label. We have the view, the cart, remove from cart, and purchase. So this transform has been transformed into a number. That means purchase stands for 1, then 2 stands for remove from cart, then cart stands for 0, and view for 3. That is exactly the function of this particular line here. Now here too, we want to also try to label. Do not forget also that in machine learning we want to make sure we, as much as possible, work with numbers instead of characters, because the machine will understand much of numbers. So we need to find a way to encode most of our characters or letters rather into numbers, so that we can really work well, similarly well while do the machine processing model. So here the Y label now will be holding a particular encoded number. Do not forget that here we have already transformed this one into number. So the same thing will come down here to in that particular order to see exactly how the label is going to be. All right, and also you see, if you look very well, see that this label here and this label here is a copy. So we have the same copy down here. So that means if you now come to this place here, we'll be having here the number that's 3, cast down for 0 and 3. So 0, but this is 1. That's how it's going to be, and so on and so forth. So instead of having those things at particular processing time. Now here, after we have done with storing our particular label here, the Y attribute label, we cannot drop it. So we can drop it from the table. So that means here we actually eventually drop this one down here, because you are trying to separate the targets with the features attributes. So we want to just, how do you now map? We will later map a particular row, the particular attribute. So we have a kind of attributes or features to a particular target. That is how we can really try to understand much of the behavior of the machine learning process. Now here we actually try to separate those columns that have characters and those columns that are numbers inclined. So if you come down here, there are some columns that are actually number inclined. Like here we have number here. This is purely number. This is a mix of number and characters. This is a pure this is characters. This is not this so we have that ones are just numbers, and We could also say this one too, because it's a mix of, we have the dash that's inside, so it become a kind of a alphanumeric character too. So we are trying to figure out exactly here how do you separate them. So we have some category attributes and numeric attribute. Now this means number, this means categorical, right? And also this particular program, because it is not just an output of you buy or you don't, are you buying or not buying? No, it's a kind of a classification. Okay, it's not a binary. You buy or don't buy. So it is, that's a big kind of a categorical classification where we usually you buy, you remove, you take, okay, you purchase or you view. So it's more than just binary. So let's come back here to another function to separate the category data and numerical data into different array. So the first one here, this one here will be holding what is called the categorical attribute, while the second one will be holding the numerical attribute. So it's just a way to just separate exactly the row into those columns that have numbers separate and those columns that don't have numbers separate. I mean, that basically kind of alphanumerical, okay, separate. So that is what we have it down here. Now here we'll just print the first three heads. So another function is there called encode data. Don't forget again that machine learning or machine development learning work very well with numbers. So we have to find a way to convert our particular values or data to numerical data. So this one is called encoder function, just to make sure that thing is do. So we have the particular two arguments. One is data frame, one is drop list. The list we want to drop out of the whole column. Now here again, look very well again. Here we have, don't forget that this function here is exactly to separate categorical and numerical number. It has been called down here with data frame sent to it. So here now we have the numerical attribute and categorical attribute. They are both arrays that contain this particular value. So here we make sure that every numerical array, every numerical attribute, the column name, okay, all right, and then we'll send them down here. So we have an array that holds the real table based on the column names sent to this place here. Likewise this one here too. So now we have what is called a pipeline. A pipeline is a way to combine different scenario of activities one at a time to the next one, then to make sure you have an entire encoded application. So we have the input sample inputter, we have the standard scaler, then this one is just to make sure that if something is missing out of a table, we can put something to fill it up. So you fill it up with 0 if nothing is there. Now here is just to make sure to standard scaler, find a way to have a standard particular range of values within a particular group, so that you know at line or form outside the scope of a particular range of numbers. So if that one's a little bit clear, we cannot come down here to transform the data exactly, because we need to transform data here. So see, I have numerical, the category one encoded to use to encode the category data here. So we need to drop also the line of the target value, and that is exactly what you are dropping here is the y value, the label, the y label. We've eventually drop that one, so that then, or this one, drop that one out of the column. That is why exactly we have it down here. Now if that one is okay, we will now come down here. You see, this is what we want to drop. We want to drop this one. Don't forget that, and this is a function that we just create above, and it's being called down here. This is the data frame, the copy sent to this place, and also this one is what you want to drop. This is the event, the behavior of the user on the platform. So after that, now we will now come down here and actually divide our data set into a training and test. You have S training and the test. So this means you have X, that's the feature S train, to change its feature to train. Now S test, now the feature for the test, we have to develop and divide our data into two sets, the train and the test. And here exactly means that we want to make sure that the test has a 30% of the data size here, and the train is for 70%. Now if we have this train and data set, now it is a little bit much time to have a machine learning brain and call and develop here. So we first have to develop a machine learning called random forest classifier. That one can be called here. Don't forget that it was even called above here from the import here under this place we have its random forest classifier for the scaling ensemble. So when now come down here, we'll now make sure we call it to this particular parameter variable 0 random state 0. That means you don't have to create a random selection of the variables within the algorithm of the random forest classifier class. So this particular line is where we now try to train our model. Alright, so we have the S train and Y train. The S train is the features that we want to just compile and see and try to understand each particular record, a particular line to a particular target. So each record to a particular target, each record to a target. It's just like having this one this way, that we try to make sure that if this is our target here, so each particular record target a particular line, each particular record target a particular one. So this 5, this record 5, all its features starting from here above down here, we need to target this one. So that is how we map features to a particular target. So this one is a way to train the model to understand the behavior in that format. After that one is being done, we try to find out the score, model score here by S test and Y test. Here is to give us a prediction and Y, that's in the prediction based on the test value. See, we train here with things, but we now here predict it using the text. But here is for the train, use text here to predict it. So that's how we do that for the random forest classifier. So this one is just to make sure we want to get exactly the best parameter that can be used for the parameter call, but it's not really so a big thing here. This is our model here. Now if we now come back here, I think our program has almost run finished down here. Now fine, it has run finished down here. Let's see exactly. Okay, now if we now come up down here, I want to show to see what is going on. Okay, now this is our random forest classifier. The random model score is 0.732 and random forest classifier accuracy is 7.34. But if you use some parameter that this best parameter like maximum features 10 and n estimator 30, we will have a kind of an improved model based on the tweaking of the parameter. So our random forest classifier has exactly 0.74. Now also here too, we do the same thing for the machine, do the same thing too for both the k-means algorithm and also the multi-layer perspectral algorithm. And here is for the k-means algorithm. Started from here. Now the k-means algorithm and also the multi-spectral. Okay, the k-means started from here, and we have the multi-perspective algorithm started from here too. Multi-layer perspectral algorithm started from here and ended here. So the same procedure, we'll call the class on it. All right, we try to train it. After training, they will not predict it. The prediction is exactly here. You see. So that is that for the code, and I will also drop a link to my GitHub so you can also look at the code effectively very well. Now here, let's try to see again, because actually it's about data and the understanding data here. Now this actually has to do with the category and the category on the data here. Okay, I want to see exactly. Okay, fine. Let's come down here. It's too much. Okay, now this are just a kind of a little kind of a histogram to understand how the product itself look within each event category, product ID, how they influence the event, the price to how it influence the event user section, how it influence the event. So I think the product ID, the category ID has a high influence here too, the price too has a high influence. Now if we come down here to this particular graph here, we discover that we have our purchase to this. So this is a price against our behavior. Now we'll discover that the lower the price here, the higher the view, and the higher the purchase too. Now as the price increase, the purchase reduces, and also as the price increase we see that in the carts the amount of things that's put in the cart does not get so much, but what is viewed and what is being purchased and what is being in the cart are based on the price. So here we see that even moving from the cart to sometimes could be also be determined by how the price is to, or probably the cost of the product. But you see that the purchase has reduced as the price goes higher. Now we now come to another category ID. Category ID too is a bit well spread, but in category ID, the user highest view a particular category of products based on the ID, or based on the category of the product. It can have a highest view here. Likewise too, the purchase can also be based on the kind of the products they are buying. Now if you look very well here too, there are different histogram too for the view cart remove. So here too is another way to analyze the behavior. So this is product ID, so determines how much at a particular time it is. So this is scatter and k-means, a cluster k-means and graph, and here the k-means actually did not do very well because everything is not well grouped. So most of the events are being scattered and not well grouped. So probably the k-means does not really learn very well on this particular project. So let's see exactly what is the score of the what is accuracy of the k-means down here. Now if you come up here, okay, we have it here. Now if you look very well, random forest accuracy has the highest, followed by multi-layer perspective accuracy 0.6650. Meanwhile k-means silhouette score accuracy of 0.39. Wow, that is too bad. Now it means that the k-means algorithm does not work very well with this kind of data. So our best take for this kind of data is actually the random forest algorithm. I think at this point a little bit is a little bit understood, I'm sure. Okay, so thank you so much for your time.